Hi guys, I hope you are doing well. Today I want to speak about the parallel hybrid vehicles, how it constructed and how it produces the power. In the next slide we have the components which contains the parallel hybrids. First of all is the fuel tank, we have engine, we have wheels, we have battery, converter. The duty of the converter is to convert AC voltage to DC voltage with the help of the diodes and rectifier. We have electric motor that acts as a generator also, reduction gear, differential or transaxle. This one it depends that the vehicle is a front wheel or rear wheel. If it's front wheel, transaxle; if it's rear wheel, differential. So in the parallel hybrids we have gasoline engine or that's petrol engine, fuel engine. In the fuel engine, it's actually primary power produce source, ICE, then ICE engine attached with the transmission and the motor. So transmission, motor or generator and gasoline engine, all these three are attached together. Then it will rotate the reduction gear. So these components are rotating the reduction gear. If we have a motor, this motor take power from the inverter. Then the inverter also takes power from the battery. And the gearbox attached to the engine and motor. The gearbox also attached to the engine and to the motor. If the wheels need less power, the excess power it will use to charge the battery. Excess power in the generator, it will produce or it will recharge the battery. It has a excess voltage. How it produces? It produces with the help of the gasoline engine because it's rotating with the speed of the engine. For the definition slide, mild hybrid technology combines an electric motor and an additional 48 voltage battery with a conventional engine to help reduce emissions and improve fuel economy. At the lowest speed, the electric motor it will rotate the wheels, but at the higher speed, most of the vehicles at the speed of the 60 km/h, the IC engine will start, or at the 80, it depends on the companies, or even in the RPM. If the RPM it goes more than 2.5 or 2500, so the IC engine will start to work. At low speed, a stop-in-gear technology can switch off the engine when the clutch and brake press together. If the vehicle has an automatic gearbox 80, so that those clutch it's not in the manual that to press, so we have a sensor and we have solenoids. The vehicle then costs whilst still in gear with the clutch and brake that's still pressed, saving fuel and reduce emissions. Auto start stop is enhanced, starting the engine around 300 milliseconds, and when accelerating, stored energy is used to provide torque during normal driving. It supplements the combustion engine to save the fuel. When coasting, the vehicle is coasting or braking, the electric motor acts as a generator. And this type of the vehicle that has a start-stop, auto start-stop type, that's start the engine at 300 milliseconds. In the HVAC system of them, almost is the same of the other vehicle, but the evaporators and the condenser of these vehicles bigger than the normal types, because when the engine is stopped, is not working, the pistons are not rotating, so they have to store more air inside at the time when the engine is not working, because if the engine is not working, so the compressor can't compress the air. That's why they have a bigger evaporator and bigger condenser. ICE engine is coupled with transmission, then there is a mechanical component to rotate the wheels. Transmission attached with the traction motor or that motor generator. that is takes power from the inverter by battery. In electric motor, everything will start from generator and then battery. When the vehicle is off, when the engine is off, so everything is with the battery. But when the engine turn on, the generator will supply the electric to all other components, even to the battery, and it will recharge the battery. There is a mechanical connection between gearbox to engine and motor. The motor can be charged by battery. The motor acts as a generator, and parallel hybrid system have ICE and electric motor in parallel connection to a mechanical transmission. The battery is rechargeable during regenerative braking and during cruising, as there is a fixed mechanical link between the wheels and the electric motor. So to charge the battery, the vehicle should move. Even for the regenerative braking, when you are moving, so in that time you press the brake pedal and it will cause to charge the battery. It has advantage and the disadvantage. Advantage, during a long distance highway drive, the efficiency is higher, for sure is higher. And even at the side of the fuel, you are using less fuel, mostly in the traffic in the cities. Flexibility to switch between electric and ICE power. Use a smaller battery pack than series drivetrains. Parallel hybrids also use the motor as a generator for extra recharge when power requirements are low, similar to an alternator in traditional cars. It can deliver improved performance, emissions, and economy. For the disadvantage, almost complex system, because the engine, gearbox, and traction motor or generator, they are connected parallel type, and then if it's front wheel, the transaxle also there it should be, and there is a generator, so it's a little complex system. The ICE, it doesn't operate in constant RPM range, so the efficiency drops at low rotational speed, additional weight and cost when compared to ICE vehicles, because it has much more components. Thanks for your time and thanks for your watching my videos.